almost ready.
We're ready.
You know, they are going to show us the last 2 semesters worth of work. Group 17, whenever you guys are ready.
All right. Hello everyone, good afternoon. My name is Gustavo, here with Esther, Ramsha, Jackie, and Chad. So I've always believed that we as human beings have total control of our lives, whether it's to wake up for a simple jog in the morning. Even though we do have this total control, some people don't possess this freedom. For our design project, not only did we want to create something innovative, but we wanted to target and have an influence on the community to give them back that freedom that they once obtained or they never even had at all. Ladies and gentlemen, I give to you the bicycle system. The bicycle system is intended to give a user who is visually impaired the freedom to ride along a specially designed track. Not only can this system keep stability, but it can even sense objects at a distance for safety precautions. I'll let Ramsha get into more details.
All right, thank you, Gustavo. So, given that there's 10 million blind people and very few devices to help them with daily routine, the thing that we're most familiar with is the cane that they usually use to navigate. But when it comes to outdoors activity, there's very little or few devices to help them with that. So, the goal of our project was to design a tricycle that could be integrated into a specialized track using sensors and motors as inputs and outputs.
The reason why we decided to use a tricycle is that it gives more equilibrium to the rider, and also because the movement of the handlebar is more limited than the one of the bicycle, so it will be safer for the rider since he cannot see.
Okay, so here's how the system works. We have a track, maybe we can lay it down later. So this is what our track looks like. It's it's a white region and it's sandwiched between 2 black regions. So the way this works is the user would get on the bike and the goal is to make sure they stay within the white region. So anytime they deviate right or left, these LDR sensors would trigger the buzzer and the handle to go off. So anytime someone deviates right, it'll trigger the right buzzer to vibrate, letting the user know how to navigate back to the track. And the same thing with the left one. And another thing that we added was if someone's approaching the user, we have a sonar, so it lets the user know if someone's approaching, we have a buzzer that will start beeping, letting them know.
So as she mentioned before, we was talking about the track being a certain range to where there's enough safety for the user to where if they go too far off to the left, they'll be safe enough to where they'll have enough time to go back into the white. Same for the right side. Also, when the track goes into a curve, we managed to turn the pegs around so that they can be at an angle to where they can read the line as it's approaching the curve, so that as it's going on, it'll let you know immediately that you're coming to a turn to where you can just follow with the signal that the device is giving. So that helps with the track.
So how does it work? So we use the concept of the LED sensors. The way that it works is it shoots out a beam of infrared light. Upon hitting the surface, depending on the color of that surface, it reflects the beam back at an intensity. And if the intensity is low, it will send the user a output to the handles and notifying them to realign themselves in the line.
The second sensor we used is an ultrasonic sensor. What it does is that it sends sound waves, and then whenever it detects an object that is 10 feet or closer, it's gonna trigger the buzzer, and then to notify the rider that he should slow down and stop.
All right, so what is this bicycle system composed of? It's made out of 4 components. As you see here, we have in the bottom, the brain out of the whole operation. This is where the code goes involved. And then the second board will be a motor mount where we have our motors connected to where we will receive our outputs. And then the third one would be the battery. The battery is rechargeable, which is convenient in case the system dies off. And what the battery does is you charge it up to for about 8 hours, and it can last up to about 48 hours. So it's a good, dependable system. 48, 50 hours.
Okay, in terms of cost analysis, our initial prototype, including the tricycle, the microcontrollers, the sensors, and the 3D printed objects, came out to about $590. If we bulk produce it, meaning if we manufacture 1,000 of these parts, we were able to bring down our price to $397. And the retail price, including markup, profit, retail, so that our retail price was $800.
Okay, so during the design process, we had to figure out how to integrate all these sensors into the system. So we had to design quite a few frames and sensor pockets to enable us to integrate the sensors into the system. So we designed and 3D printed all the sensors that you see there. The casings. Our competition so far was is no longer in existence. They were called the Ultra Bike, and what they did was they used a system of sonars, angled slightly. I think it was a 5-degree angle, and it was designed to be ridden in tandem with someone that could actually see, so that they can kind of help the visually impaired person navigate. So we designed a system that the visually impaired person can actually ride on their own unassisted without someone who can see helping them. And so there were a few modifications that we made during the design process. Initially, we started with a track that included just a black line with 2 white lines on the edge, offset. And then we decided to settle on the line follower system because we felt that it gave the rider a lot more safety because it constrained them a little bit better.
Another change we had to do is, at first we only had the infrared sensors, but then we decided to add the ultrasonic sensors so that we can avoid obstacles. And for the motors also, we had to go through a lot of different motors. And some of them were too big and the battery could not support it. But then we ended up finding motors that fit well and then vibrate just enough so that they don't scare away the rider.
For the installation, we managed to get the wires inside from the handles all the way to the wheel. We 3D printed some pegs in order to give it that distance for safety. Once again, that if it was too close, that if a wheel went out on the right side, then both will be reading on the right. So the extension was due to prevent that from happening. The wires here connect to the Arduino board onto the output, which is the motor, as you see here. Here we put the rubber piece over it just so that the user, while they're holding the handleboard, will be able to feel the vibration and let them know to move on to the right or to the left. And here we're just showing an example right here, such all going into the main component.
As for the future consideration, we thought that instead of having just one single unit mounted on the bike, we will make it more compact so that we'll be able to integrate it to different devices.
And we also wanted, we foresee a system that is a little bit more improved, a much more intelligent system that will allow the rider to get out of the of just the system of just a supervised track and be able to ride in all terrains.
And one of the main focuses that we would like to put our energy to is if they perhaps, the city of Houston could open up a park for the visually impaired so they could mount on and, there could be a way from people who are not visually impaired, right? So for safety precautions whatsoever. And the main thing that I want you guys to focus on is the system. The system is intended to be put in any device that the handicapped person or visually impaired person desires. It could be a tricycle, it could be even a small scooter, depending on,
So you guys can see that in action. Is there a voice on here?
On the side there is a body.
have the track if you allow us to present you some, quick demonstration.
If it's okay.
If it's okay, Professor.
We have time to demonstrate.
We will check after the presentation is over, but thank you very much.
We want to thank y'all for, taking the time to look at our project and hearing us out of what we proposed, and we want y'all to take into consideration the potential that this project can have. However, in the sense that for future and more enhanced, sophisticated projects, because we are limited, with our sensors and with our system itself. But if we did have, more funds, and of course there are some more better sensors out there, and it's just the fact that they're more expensive. They're about $500 each, and that one specifically reads the color specifically. So we saw that into consideration, but we're limited to it. So if you have any questions then we'll be happy to.
Yes.
So first of all, let me commend you. It's a wonderful team to come with the technology, using the technology to help the visually impaired person to be able to do the exercise like we all do, right? We all enjoy. So that's wonderful. Wonderful. That's what engineering is about, right?
Yes.
That's what we engineers do. Thank you. And then so I have a couple of questions here. Number one is, what was your choices on this, sensor, instead of the, whatever the existing system, existing product you have? How did you come with this new approach?
We looked at the markets, and we were trying to see what was existing for blind people in terms of exercise, and what we got was the system that was using just the sonars, and the rider had to ride in tandem with someone else who could actually see, just to guide them. And so we thought that we might want to have a system where there's just a supervised track, and the rider can just ride on their own, just based on the system of sensors that we put together to enable them to navigate along the track.
As for the sensors, though, we did see some that are available, and these, the one that we have, they're actually the ones that, due to our budget, of course, these are the ones that have a longer detection distance, and the other ones that were on the market, they sensed like half of this distance. This reaches a maximum of 10 inches, and then the other ones will only reach about 4 or 3. So this was the better option that we had. And there really isn't anything out there specifically, like how you're saying, like specifically for the blind that can help them. Because what they use ultrasonic sounds for the Ultra King, and that's about it. But by adding these infrared sensors on into the tricycle, into the system itself, it gives them a little bit more freedom. You see what I'm saying? So in the sense of that they're the controller now. You're not depending on a man-made PID controller. You're the controller now, rolling through the ground by the help of these sensors.
Thank you.
Yes, ma'am.
Have you run the basic concept past any visually impaired people or visually impaired groups?
Yes, ma'am. We actually went to go visit a blind society, and they were very interested in riding the tricycle, because they did tell us that for the blind, they're kind of outcasted, they're forgotten. So there's not really much out there for them. So he did mention to me that if we do make this system possible, that he wanted to be the first one to ride it. And he's actually the president of this organization. It's called Helping Blind People. So he's willing to ride it. We did have a meeting with him last week, but he is a busy person because he has conventions that he has to go to. So we had to reschedule. So we couldn't get a chance to communicate with him, physically.
I guess my primary concern is that you need a special facility to use this vehicle. And so, I mean, is that facility, that would have to be used exclusively for this type of vehicle?
Yes, ma'am.
So how practical do you think that is?
We believe that a project like this has to be in part funded and supported by the local government authorities. Mm-hmm. So we were foreseeing a system where we could kind of cooperate with the city of Houston and open a public space for the blind people so that they can be able to ride it, because this is not something that can be successful in a private setting. Just like with the art competition, they had to go out of business because they didn't really have that public funding from the government. It was actually a system that was invented in the UK.
What I'm trying to get at, I guess, is you said one of the benefits of this system was that the blind individual could operate this independently, rather than the alternative system where they had to be guided. So these parks, if they were built, would be relatively rare. I mean, we have enough troubles getting, bike paths and for the entire population, let alone the small set of the population who is visually impaired and wants to ride a bicycle. So you're looking at 1 or 2 parks in the largest cities in the country. And so this isn't going to be something in your neighborhood. So how do they get there?
There's actually 3 blind centers right real close to each other by Buffalo Bayou Park. So that's one of our main targets there where we could put the park in there. Because why? In case they want to go out for outdoor activities, they could just go to the park, and Buffalo Bayou is right there. So that would be a good setting to have this park in.
Because I'm just thinking, if you have to have someone else drive you and your bicycle and your tricycle to this track, and then are you really independent at that point? And
you're independent while you're riding it. Of course, someone has to be watching you because you're not 100% safe because of the fact that the person is blind. But by having someone guide you to it, and maybe just keeping you a distance, keeping an eye on you at a distance, the rider still has freedom to move around, feel the air, smell it, instead of just being in a room and just riding a regular stationary bicycle. So this is something that we think it's really good for the people.
I'd be curious to see if you actually could manage a regular bicycle. I think in the right conditions, you might actually be able to make that work under similar circumstances.
That's not stability enough.
Yeah, we just thought it would probably be harder for someone who's visually impaired to kind of learn how to ride a bicycle.
About the entire project, we just put safety first. So
that's true, but many people become visually impaired after they already know how to ride a bicycle.
Right.
So it'll help.
So you have these pegs on here that you 3D printed and designed, and then you've got the sensors in them. I didn't see a stress analysis on your parts. You hit a bump, you snap that thing, right? You lose your sensor. So how strong are these pegs?
Honestly,
our pegs. Okay, so. We ran a stress analysis on the actual box based on the local conditions here in Houston, and it came out very stable. This is kind of anecdotal evidence, but that's kind of what we have now. But as far as the pegs, and I designed those, and I was able to just throw them to the ground, and they were quite safe. So I know it's not exactly a stress test, a traditional stress test, but we were able to just, I was able to put them together and throw them on the ground, and they didn't fall apart or anything like that.
We also assume that since the person, you got to remember, the person is visually impaired, so this track will be fairly new without no bumps. So,
you're hoping they're not hitting potholes.
Yeah, so there won't be no step changes involved. Yes, sir.
Let me help you guys to answer those 2 professors' questions. Because I'm very impressed. This is what engineering is about, right? We want to improve the human society to benefit mankind. This is a very, very wonderful, excellent project.
Thank you, sir.
So they are in the concept stage. If you look at the engineering project, there are several stages: concept, feasibility, development, prototype, field test, commercialization. So you guys are far away from commercialization, trust me. You guys are between concept and the feasibility. This prototype is way beyond this already. So this is a typical engineering project phases, right? So beginning, let me say this. I am just so impressed with this project.
Thank you.
With all the projects I have listened to today, this is the one going to help the society. And you should be able to get a proper funding from the society. You know, if you go to the right organization, they will fund you, right? Even write to Mr. Bill Gates. He has so much money. He allocated so much money for this, whatever, the vaccines, whatever. This thing should be proposed to those kind of organizations. You will get the money. Trust me.
See you
And
now.
by the- yeah. So let me finish. The other thing I'm impressed, let me go with this one. So I was finished with this, right? I'm very impressed with this too.
Yeah, walking in and
Yeah,
handing
that's
that off. I
I
thought
tell
that
you,
was a smart
no
move.
engineering team, at least I didn't attend all the engineering team presentation. But you guys have this. It tells me something you guys ahead with other team. Because you need to have a user manual, operation manual, maintenance manual, parts, everything. So this is the beginning. But this is a wonderful example about the engineering project should be pursued in the engineering school. Thank you.
Yeah, and building on that, I want to say I am really pleased to hear you actually did talk to Visual Impaired Society, because, you know, I guess I was going off of my own biases. I thought people would have rather just, you know, if you're going to have to drive, if you're my initial thoughts were, oh, if you're going to have to go slow in a tricycle, why not just walk? But, and so I thought, oh, maybe you didn't even talk to anybody, you never even asked anybody. And I thought I was going to get you.
Yeah, you
And
did.
I thought I was going to peg you.
Yeah, you were done.
You were done. But then you said, no, we actually have asked people, and that, so you just thanked me instead.
The president of that company did, however, say that he did tell us in the beginning. He was like, don't just focus on the tricycle, because I proposed to him the tricycle. I told him, yeah, we want to do the tricycle that's going to help you, you know, ride in a field. And he did say specifically, don't focus so much on the tricycle, but focus on making a system that's detachable and that you can put it in anything. He gave me one brief example. Think about somebody who wants to just walk, but doesn't know how to guide themselves through it. Maybe the system can be embedded in a little roller that you're just guiding yourself through it like this. And you see, that's another bicycle system.
So
Exactly.
I guess the biggest worry I would have with this, especially see the tricycle, is like what you don't want to like. Okay, imagine if let me go to the extreme. Let's say it was a tricycle with a bunch of gearing on it that kept it going over 2 miles an hour, and it was covered in a bunch of foam rubber, like Nerf padding. And you tried to give that to somebody. While that would be in theory safe, you would be demeaning them. I mean, that would be absolutely
taking control.
Yeah.
That would be just insulting to someone to try to give that to them. So you have to take that very fine line where, yes, you do want to protect people, but you also don't want to patronize them. And so that's the fine line you do have to walk with this type of system. So, but I think you've done a pretty good job with that.
Thank you. We really appreciate it.
Thank you. Thank you.
I do want to give thanks to a person in here that really helped me out a lot, provided me with their mentorship and, you know, their strategy to make this project, you know, present here for y'all to see is Professor Wiggins, Nathaniel Wiggins. He's been my professor He's been my professor since I started college, and if it wasn't through him, I wouldn't have been here, you know, talking about this project, engineering related, because thanks to him, I'm pursuing this career.
Yes.
Thank you.
Thank you.